none of this that we're doing is brand new to you. Like I said yesterday, you did this in 8th grade math, which some of you took in 7th grade. You may have kind of done it all together and it not have been split up by not even looking at parallel lines the first day. But I find that sometimes there's a confusion about the fact that the angles exist regardless of whether or not you know anything about their measurements. Like you have alternate interior angles or corresponding angles regardless of whether or not you can tell me anything about their measurements or if the lines are parallel or not. So that's why I want to make sure that you can see it separately. So we're going to start by looking at this. You don't have to draw this. I just want you to follow along with me because that's a whole lot of stuff everywhere, I know. And when we're looking at these angle pairs, we look at a maximum of 3 lines at a time. How many lines are in this picture? 4. Okay, there's 4 lines, right? Which means at least one of them I'm going to ignore every time I look at a different angle pair. So when we look at angles 20 and 13, okay, 20 and 13, which line do I not need at all? B. If line B disappeared, would I still have angles 20 and 13? Yes. Okay. So when you're actually doing that on your paper, you can cover it up with your finger or your pencil or whatever, just so that you can, it's just not even there to confuse you. Okay, so then you need to decide which of the 3 that are left is the transversal. The transversal will always be the one that's touching both of the angles. So for 20 and 13, line A has nothing to do with 20, right? And line C has nothing to do with 13. So line D is your actual transversal. Make sense? Then you got to look at the interior and exterior, and that's when it gets weird when it looks like a triangle. Okay, and that's what some people are having a hard time comprehending, and I know because it's a little weird. D is my transversal. A and C are the lines. So the interior is just between those lines. This is the interior of those 2 lines. Not just this part inside the triangle, but whatever's in between those 2 lines as it goes on forever. It's a different way to think about interior instead of like interior and exterior of the triangle, because it's not always a closed space. So anyway, so now I'm looking at 20 and 13. All right, so then when I look at 20 and 13, are they both on the inside or outside? Inside. Okay, then you look at how they're related to the transversal. Are they on the same side or opposite sides of the transversal? Opposite. So if they're both on the interior, there's something interior. They're on opposite sides of the transversal, so they are what kind of angles? Not opposite interior. Alternate, yes, absolutely, you can take it. Alternate interior angles. Okay, so do you see how to look at that? You see how to think through it? Okay, so now let's look at 18 and 15. Which line do I not need? B again, right? And then for 18 and 15, which one is your transversal? C. Line C, good. So if line C is the transversal, these are the other 2 lines. And so this is the interior, because it changes depending on which ones I'm looking at, right? All right, so then 18 and 15, are they both on the inside? No, both on the outside? No, that means they're not interior or exterior anything, right? That narrows it down greatly. Are they in the same position? Yes, so what's that called? Corresponding, okay? If one's inside and one's outside, it's not anything interior, exterior. I hear that sometimes. It doesn't make any sense. So they're in corresponding because this is in the top right and this is in the top right when you look at them as sets of 4. Okay, we all good so far? Stop me if you have a question or if I lose you somewhere. All right, now let's look at 1 and 3. Which line do I not need? Find 1 and 3. I don't need A. A can disappear. 1 and 3 still exist, right? And what type of angle pair are they? Corresponding, because again, they're in the same position, right? We all okay with that? All right, and then 17 and 4. So what line do I not need if I'm using 17 and 4? A. Yeah, like if you're confused about how to figure that out, if line C disappears, does 17 disappear? That's a problem, right? But if line A disappears, 17 and 4 are still there, so A is just completely irrelevant. So I ignore A. My transversal is what? Line D, which means this is the interior, right? Because I'm ignoring A. So for 17 and 4, both on the inside? No, both on the outside? Yes, so it's something exterior. Same side or opposite sides? Opposite, so that means they're alternate interior. Very good. Okay, good. All right, now look at 14 and 11. Which lines do I not need to create those angles? B. B. Could I lose B and C and still be okay? Yes, okay, because it only takes 2 lines to create those angles. So they're not going to be same side, alternate, none of that stuff, because all those require 3 lines, right? What type of angle pair is that? 14 and 11. Linear pair. They are a linear pair, okay? Which they are supplementary, but linear pair is the name of the angle pair. And so we know that, what do we know about linear pair? They are supplementary, okay? And that's the case no matter how many lines are drawn on there, but it only takes 2. If we go back and look at 17 and 4, and those are alternate exterior angles, do you know anything about their measurements? No, you don't, right? But linear pair, that's stuff that we had already talked about before then. They still exist here. They're going to be important to us, but we know that they're 180 and that hasn't changed. All right, so then we look at 1 and 7. Which lines do I not need? A and D, right? Because again, it only takes 2 lines. Yes? What type of angle pair is that? Vertical angles. And vertical angles are congruent, right? And it doesn't, you don't have to have 3 lines for either one of these angle pairs. You don't have to have 3 lines. You only have to have 2 because they're like a different classification of angles. Okay, we good? Any questions? Does that maybe clear up a few things from yesterday? Good. Okay, good. All right, so now let's move on to the notes for today. This is going on page 45 when we're done. Now, because of Harvey, I chose, instead of trying to just do things even faster than I already have to shove it down your throat, I decided that we're just going to kind of leave some stuff out that I would fill in along the way, because it is important. And one of the things is the whole symbolic logic thing. That probably doesn't even mean anything to you, but it seems much more like English lessons when we're going through them, because it's a lot of writing and we're talking about forming sentences and stuff. But it's important because it's how most of our postulates and theorems are formed. So if you just look at this sentence, the way it's set up is if something happens, then something happens, right? So that's called a conditional statement. If it is an if-then statement, it's a conditional statement because conditions are put on it. If you clean your room, then you can have your phone back. That's a conditional statement. Your parents probably use those kind of statements with you all the time, right? You know, if you're pass your classes, then I won't have to kill you, right? Something like that. Or if you get all A's, then, you know, you get, I don't know, some people get money, whatever. But those are conditional statements, because if I use the if you clean your room, then you get your phone back, if you don't clean your room, do you get your phone back? No, right? Because it's if you clean your room. The only way the second part's going to happen is if the first part happens. Does that make sense to you? And so that's what's happening here. If this is true, well, if it's not true, then none of the rest matters. But if it is true, then we know some other stuff. So the forming of these sentences, this looks like this. If, and then the first part, whatever, the clean your room part of it, I'm going to represent with a lowercase p. Okay? If. What? If. No, it's a capital I. If, yeah, it's cursive, I know. We got to learn how to read cursive. If P, then Q. And I know the P and Q might seem weird, but that's part of the symbolic logic of this. You could take a whole course on symbolic logic in college, and it's just how, you know, it's more about how things are formed and how what the truth values are, and the actual content doesn't even matter most of the time. But if P, then Q. That means if whatever P is, if this doesn't happen, then Q isn't going to happen. If this does happen, then this does happen, all right? So the abbreviation for this looks like this. P and then the arrow and then Q. You don't read that P arrow Q. It doesn't mean P is going to Q or heading to Q or nothing. P's not, you know, just point going to Q. It doesn't work that way. When you see the arrow, that translates into this. So if, when you see this, if the word is if isn't there, but if P, then Q. That's how you would read this right here, okay? Because that's how we're going to abbreviate some of these, because trust me, you don't want to have to write these out word for word. It's a lot of words, and the more abbreviating you can do, the better off you are, but you have to have this make sense to you first. And it may seem a little weird. I know it does. I know I'm just throwing it at you, but you'll get it figured out. It's really not that big of a deal, okay? All right, so now let's look at the actual postulates and theorems that go along with these lines. Now, what we have today, which we didn't yesterday, I still have 2 lines cut by a transversal, but now they're 2 parallel lines, which means there are going to be special properties about these angles. And so this starts off with if 2 parallel lines are cut by a transversal, right? Is that what I have? Yes? Okay. Then, so since I do, then this happens. Each pair of corresponding angles are blank. All right, so look, let's just find a pair of corresponding angles. Let's look at 7 and 2, right? Now, when you look at these as two sets of four, just like I told you yesterday, this set of four and this set of four, when the lines are parallel, you can think about taking this first set of four, you can pick it up, and you can set it down right on top of the second set of four, and they all match up exactly right. Okay? So if that's true, then what do you think has to be true about 2 and 7? They are congruent. The word is congruent. So if 2 and 7 and 2, they are corresponding angles, and since the lines are parallel, that means they are congruent. Does that make sense to you? Okay, so I'm going to mark them as congruent. I'm going to put 2 little arcs on 7, 2 little arcs on 2. And that is actually true. Now notice that this one is a postulate. Okay? It's a postulate because I can't do a mathematical proof for it, but there's all kinds of things that can happen where we know that that has to be true because everything else is true. Now, the way you abbreviate this, it looks like this. That's why you have space down here. 2 lines, parallel, and then we'll do the arrow, then abbreviate corresponding angles are congruent. Okay, so that's what the abbreviation is, so just write that down and I'll kind of talk you through it. Remember, when you see the arrow, and the arrow will be in the middle, so it's like you see it first, but you know that that means that this is a conditional statement. It's going to be an if-then statement. So if 2 lines are parallel, then the corresponding angles are congruent. Does that make sense to you? I also chopped off a whole lot more because it really should be if 2 parallel lines are cut by a transversal, then, but this gets the idea, which is the important part of this. So are corresponding angles always congruent? No, only when 2 lines are parallel, right? They are not always congruent, but if the 2 lines are parallel, then they are congruent. Does that make sense to you? That's why you need that first part. I can't just say corresponding angles are congruent, because we looked at a whole lot of angles yesterday that were corresponding, but not congruent. So that's why we have to be specific here. All right, so let's write these out then. We've got angle, what do we use? 7. So we got angle 7 is congruent to angle 2. So what would 8 be congruent to? 4. Okay, good. And then angle 1 would be congruent to 6. Good. And then angle 3 would be congruent to 5. Okay. Everybody okay with that? Right, so all the rest of these are theorems because we can prove them. And we actually use the corresponding angles postulate and a couple of other things that we know to prove each one of them. So we're going to kind of talk through the proof. We're not actually going to write out the proof or do it, but just so you can understand the thought process. Because really, all I have to teach you is the corresponding angles. Everything else comes from that, and you can figure it all out without all this stuff anyway. But this gets you there a lot quicker than having to explain 1,000 steps to get there. So this starts off by saying, again, if 2 parallel lines, right? So yes, I have that. Then we're going to look at the alternate interior angles. So let's look at what's happening up here with these. So let's look at angles 3 and 2. Are those alternate interior angles? Yes. Okay. So 3 and 2. Well, I know the 2 is labeled, 3 is not. But tell me what type of angle pair is 7 and 3? They're vertical angles, right? So 7 and 3 are vertical angles. What do you know about vertical angles? They're congruent. So I can put these 2 little marks here. 7 and 3 are congruent because they're vertical angles. 7 and 2 are congruent because they're corresponding angles. That means that every single time that happens, guess what? 2 and 3 have to be congruent. Does that make sense to you? So by using vertical angles in the corresponding angles postulate, I can tell you that the alternate interior angles are always going to be what? Congruent. So then to abbreviate that, we got to start again with 2 lines are parallel. Then alternate interior angles are congruent. So angle 1 is congruent to what? Angle 4. And then angle 2 is congruent to angle 3. Everybody okay with all that? So again, there's another theorem. So we'll start off again with 2 parallel lines. And then I tried to change everything back from consecutive to same side, but clearly I missed it again, but that's okay. We're just going to mark through consecutive and change that to same side. It means the same thing. It's probably good that I actually did leave it just so that you know if you see it, it means the same thing. Same side is just more common, and it makes more sense, and I'll explain why here in just a little bit. But All right, so same side interior angle. So let's go back up here, and we're going to look at angles 1 and 2, right? So 1 and 2 are same side interior angles. Do we agree with that? Okay. So let's start back with some of the stuff that we already know. Look at 7 and 1. What type of angle pair is that? They are a linear pair. So 7 and 1 are a linear pair, which means they are supplementary. Okay. So angles 7 and 1 are supplementary, right? 7 and 2 are congruent because they're corresponding angles, right? So I got a linear pair and I got corresponding angles. Well, since 7 is congruent to 2 and 7 and 1 are supplementary, what has to be true about 1 and 2? They have to be supplementary. Okay, does that make sense to you? All right, so then is it possible that 1 and 2 could be congruent? Yeah, it's totally possible, right? But is that, I don't know for sure if they are or not here. I can't go by the way it looks, but I can tell by looking at least I think that they're not. There's no way that they're always congruent, right? If we change that stuff. It is a possibility, but so I can't label that they're congruent. Instead, I need to label that it's different, so I'm going to put 1 mark on angle 1. Okay? Just to show that it's different than 7 and 2. Let's come back down here. And so we said same side interior angles are going to be supplementary. So to abbreviate, 2 lines are parallel. Then SSINT, same side interior angles, are supplementary. Everybody okay with all that so far? All right, so there's not a symbol for supplementary, so I have to actually show that they're supplementary. So we'll start with angles 1 and 2. So the measure of angle 1 plus the measure of angle 2 has to equal what? 180. And then the other pair is 3 and 4, so the measure of angle 3 plus the measure of angle 4 is also equal to 180. Any questions? All right, so alternate exterior angles theorem. So we're starting again with if 2 lines are parallel. Then we know something about the alternate exterior angles. Right? So let's go up here and look at some. Let's look at 2 and 5. Right? So 2 and 5 are an alternate exterior angle pair. Here's what I know. I know that 7 and 2 are corresponding angles, so they're congruent. What type of angle pair is 2 and 5? Vertical. And those angles are what? Congruent. Okay? So since 7 is congruent to 2 and 2 is congruent to 5, what has to be true about 7 and 5? They're congruent. That's the transitive property of congruence. You're cutting out the middleman, right? 7 is congruent to 2, 2 is congruent to 5. That means they all three have to be the same. So alternate exterior angles are congruent. To abbreviate it, start with if 2 lines are parallel, then alternate exterior angles are congruent. So we looked at 7 and 5. So angle 7 is congruent to angle 5. Then the other pair is angle 8, congruent to angle 6. So then another theorem. 2 lines are 2 parallel lines. Consecutive we can change to same side, even though it's the same thing. So now we're looking at same side exterior. So let's go back to our picture. So I'll look at 7 and 6. 7 and 6 are same side exterior, right? I know that 7 and 1 are what type of angle pair? What type? They are a linear pair. So since they are a linear pair, they're supplementary. What type of angle pair is 1 and 6? Corresponding. So we know from this that they are congruent, okay? So 7 and 1 are supplementary. 1 and 6 are congruent. So what has to be true about 7 and 6? Supplementary, right? Does that make sense? Do you understand why? Okay, good. So those are same side exterior and they are supplementary. So to abbreviate, if two lines are parallel, then same side exterior angles are supplementary. So measure of angle 7 plus the measure of angle 6 equals 180. And the measure of angle 8 plus the measure of angle 5 equals 180. Okay? Everybody okay with that? All right, so before we finish down here at the bottom, let's go back up to our picture because we have most of the angles labeled, but not even all of them. So I only have 8 and 4 that are not labeled. How many arcs go on 8? Just one, because it has to be congruent to angle 1, right? So that gets labeled like this, and then this one gets labeled like this. You could actually go in and fill in the whole picture just based on what you know about corresponding angles and vertical angles. And that can get you everything to get them all labeled. Okay? We all good? You really got to go, but you need to learn to go in a different class. All right, so let's look at this little list down here. I'm going to list this out. So the first set of congruent angles we talked about on here were corresponding angles. Right. Then we had alternate interior angles. Then what? Alternate exterior angles. What's another pair of congruent angles you know of? Vertical angles. Then supplementary, we've got same side interior angles, same side exterior angles, and then what? Linear pair. So, tell me, who can tell me what alliteration is? It's an English thing, not a math thing. What's alliteration? Good. Anybody want to give me an example of a phrase? Yeah, right? That's a good one. Sally sells, see, I can't even get past cells. But that's an example, right? So, alliteration can help you here. This is why I don't like consecutive as much as I like same side. Both sets of same side angles are supplementary. So if you just remember same side is supplementary, see how that alliteration can help you? Same side is supplementary. Don't ever try and make them congruent because same side is supplementary. And both sets of same side angles are under the supplementary category. It's good that you don't have one in one and one in the other. And both sets of alternate angles are in the congruent category. So you've got two pairs that are sets, basically. And so one of them's a set of congruent angles and one of them's a set of supplementary angles. Vertical angles and linear pair, that's old stuff. And then corresponding is the only other one. You have to know where to keep it. And corresponding and congruent both start with a C. Now, these three and the first two under supplementary, you have ways to explain yourself when it asks you to explain with a postular theorem. You can say it like this without having to say a whole bunch. So what we can do for vertical angles, first of all, tell me what do you know about vertical angles? They're congruent. So we can write vertical angles, and then we do the arrow, so that really means if they're vertical angles, then they are congruent. That way you just kind of stay consistent in how you write everything out. And then for a linear pair, if it's a linear pair, then they are supplementary. Okay. So if you can just think of them in two categories in your head, you've got two options. Either they're congruent to each other or they're supplementary. Those are the only two options. We good? All right, let's look at the next page. All right, so it says in the figure, the measure of angle 9 is 80, should say 80 degrees, but it doesn't. And the measure of angle 5 is 68 degrees. So we're going to label that. Angle 9 is 80 degrees. Angle 5 is 68 degrees. And it says to find the measure of each angle and tell which postulates or theorems you used, which means you can't just go in and fill in a bunch of numbers. You got to be able to explain yourself as you go. All right, so we're looking for angle 1 first. So are angle 1 and angle 5 a pair of corresponding angles? 1 and 5. Yeah. 1 and 5 are, it's a yes or no question. Are 1 and 5 corresponding angles? Yes, they absolutely are. So is the measure of angle 1 68 degrees? No, because, yeah, they're corresponding angles, but these two lines right here, not parallel, right? So I do have these two that are parallel, and they're labeled for me. So if I'm looking for angle 1, I have to use my two parallel lines, and P is a transversal, so I'm ignoring Q. Does that make sense to you? So be careful not to use the wrong angle just because, yeah, it is corresponding. But are corresponding angles always congruent? No, only when the lines are parallel. Good. So finding the measure of angle 1 is easy, though, right? What is it? 80. Okay, so it is 80 degrees. Then we have to explain how we know that. We know, we can label it on here, because these two angles are congruent, right? So I can say angle 1 is congruent to angle 9, because that tells me which angle we use to get us there. And then they are corresponding angles. But you can't just write corresponding angles. You can't just write corresponding angles are congruent, because they're not always congruent. Only if two lines are parallel. So you have to write two lines are parallel, then corresponding angles are congruent. Okay, everybody okay with that? All right, so then we're going to look at angle 12. For angle 12, which line am I going to ignore? Q, right? I'm gonna need W because I got to use my parallel ones, but I'm ignoring Q again, right? Are 1 and 12 a special type of angle pair? No. They have a special relationship, but they don't have a name, so we can't use those. So I'm going to have to use 9. What type of angle pair is this? Linear pair, which means they are supplementary. So what's angle 12? 100. Okay? So I know it's 100. I was able to get that because I know that the measure of angle 9 plus the measure of angle 12 equals 180 degrees. And I knew that was okay because if they're a linear pair, then they are supplementary. Everybody okay with all that? All right, so then we're going to look at angle 3. Are 3 and 5 alternate interior angles? Yes. So is angle 3 68? No. Because these lines are still not parallel, right? Make sure you're not relating it to this. I'm actually ignoring line Q because these are my parallel lines and then this is my transversal. So I've got some options. I could use angle 1, I could use angle 9, or I could use angle 12, right? I got 3 different things. So if there's 3 people sitting at your table, you could all 3 answer the question completely differently and I'll be right. Should we all get the same measure in the end, though? Yes. I mean, our explanation will be different, but the measure should be the same. What's the measure of the angle? 80 degrees. Okay. And so then I'm going to call on somebody that can give me which angle we're going to use here. So I want to know which angle do you want to use, whatever those numbers were. I forgot already. Anthony. So you get to decide. Are we going to use angle 1, angle 9, or angle 12? Which one do you want to use? Pick your favorite number. Angle 9. Okay, so we're going to use angle 9, right? Because it doesn't really matter, right? So we're going to use angle 9. So we know that these two angles here are congruent, right? And they're alternate interior angles. So I need to say angle 3 is congruent to angle 9. And then because they're alternate interior angles and the lines are parallel, that's why I got to do that. So if two lines are parallel, then alternate interior angles are congruent. If I'd have used 1, I'd have to say 1 is congruent to 3, and if they're vertical angles, then they're congruent. If I'd have used 12, then we'd have to say the measure of angle 3 plus the measure of angle 12 equals 180. And then if two lines are parallel, what type of angle pair is this? What type of angle pair? Question. Same side interior. They are not a linear pair because they are not adjacent. These are same side interior angles because this is the interior of the two lines, right? So I'd have to say if two lines are parallel, then same side interior angles are supplementary. So just different ways to explain it. All of them would be right. Okay, we good? All right, so let's look at angle 4. 4 and 5 are same side interior. Can I use those? No, lines are still not parallel, right? But I could use 4 and 3. I could use 4 and 1. I could use 4. I can use 4 and 12. Could I use 4 and 9? No, because they're related to each other, but they're not a special angle pair. So one of them, one of them takes more to write here and less here, and then the other is the opposite. So it doesn't matter. So let's see which angle we're going to use to get this one. Abraham, not here. 1. You get to choose. All right, so we're going to use, what did we say, angle 4. So to find angle 4, are we going to use angles 1, 3, or 12? 12. Okay, so he wants to use 12. That's the one I would pick too, actually. So what is the measure of angle 4, 1? 100. Okay. So this is 100. No matter which ones we use, we should get the same answer, right? So it's 100. And if we're going to use 4 and 12, they're congruent. So angle 4 is congruent to angle 12. And then what type of angle pair are those? Well, I just said that they're congruent, so I know they're not supplementary, and I know they're not a linear pair. They are corresponding. They're in the same position, both in the bottom left. So if two lines are parallel, then corresponding angles are congruent. All right, so now look up there. Are angles 9 and 4 supplementary? Yeah, 9 and 4 are totally supplementary, right? Because they add to give me 180. But are they a special angle pair? No. But any two random angles you pick are either going to be congruent or supplementary. Those are your only two options. They may not have a special angle pair name, but they will have the same. They will have the relationship. You just may not be able to use them to say something about what you're doing. Okay, so let's look at 7. Angle 7. All right, so 7 and 3 are corresponding. So is angle 7 80 degrees? No, because these lines still not parallel, right? These are my parallel lines. This is my transversal. Does that make sense? Okay, so does it even matter that my lines are parallel here? No. Okay, it doesn't even matter because what type of angle pair is 5 and 7? Vertical. And that's the only one of these 8 that I even have anything about, right? So angle 7 is 68 degrees. So then I can say angle 5 is congruent to angle 7. And then if they are vertical angles, then they are congruent. All right, so then 16. Again, these are the parallel lines. I ignore P, so I can't use any of these numbers that are up here. 16 and 5, are they a special angle pair? No, so I have to use 7, right? I don't even have an option. Okay, so nobody speak. I just want you to think real quickly in your head. I'm not even going to ask you to tell me what the measure of 16 would be. Okay, then I'm going to take you through how you should really think about it. Because most of the time when you try and spit because what's the relationship here? They're what? They are not a linear pair. They are supplementary because that's what the relationship was, not what so they're supplementary, which means I have to take 180 minus 68. Even though y'all are smart and you can subtract without a calculator. See, I haven't lost any of you yet. Everybody's still surviving just fine without a calculator. You're getting through it day by day. But you sometimes forget to carry or borrow or whatever in your head because you're trying to do it the hard way. You break things down. What's 180 minus 60? Holy heck. Whew. All right, that's back. 180 minus 60 is 120, right? Okay, so you're sitting at 120. You have to subtract 8 more. Where do you end up? 112. If you do it in pieces, you're less likely to be off by 10, because usually you're off by 10 or 1, depending on where what the actual numbers are. But it's 112. All right, so this is 112 degrees. And that's because these are supplementary, right? So the measure of angle 7 plus the measure of angle 16 equals 180 degrees. Not a linear pair. I get that a lot here, so I want to make sure you understand why. Are they attached to the same line? Yeah, they are. But aren't all these attached to the same line? They're not all linear pairs. Okay, but they're not adjacent. They don't have the same vertex. Not a linear pair. What type of angle pair are they? Same side, interior angles. Good. So if two lines are parallel, then same side, interior angles are supplementary. Everybody okay with that? All right. So now next it says to find the value of the variables in the figure, explain your reasoning with postulates and or theorems. All right. So when you look at these, it might be helpful to you to extend the lines and actually make them lines. It may not make that much of a difference on this particular one, but when you start getting closed figures or some other weird stuff with a lot going on, you actually seeing them as lines that pass through each other will help you be able to connect it to what you understand a little bit better. Okay. All right. So first, before we even worry about the question, I want to look at the one that is marked as Z degrees. What's the alternate interior angle with that one? Just 90? I'll agree with that. How many lines do you look at a time? How many lines do you look at a time? 3. So I've got to use the 2 parallel ones, and then I've got to use this one. If this line disappears, do you still think it's 90? No. But you see how when there's extra stuff there and it gets closed off, you want to say 90, or sometimes even just like the 2x, but this whole thing is actually the alternate interior angle pair. You see that? We're not even going to use it right now. I just want you to see that so that you think about. That's why the extra stuff is good to pretend like it's not there. All right, so this asks us to solve for the variables and explain our reasonings with the postulates or theorems. So that means I've got to set something up to find these. So let's just start with these two. What type of angle pair are these two? Linear pair. So that means, do I set them equal to each other? No. I just set them equal to 180. 2y equals 180. Okay, so I don't set them equal to 180. That doesn't make any sense. I add them together and set them equal to 180, or I put their sum equal to 180. Make sure you're saying what you mean, because that's going to start getting you a lot of things wrong. Then I got to explain it. So this is, if they are a linear pair, then they're supplementary. And I'm just putting the explanations in parentheses just so you know it's different than that. All right, now I've got 2 variables, which means I can't just solve this and get, oh, y equals 5 or whatever it is. So if I have 2 variables, what do I need? Okay, so 2 variables requires what? 2 equations. Okay, 2 variables requires 2 equations, right, which gives me a system of equations. Systems don't always mean that they're hard and weird and crazy, okay, but that's what it is. 2 variables, I need 2 equations. So I got to set up another one. So what about, could I do 2y and x? What type of angle pair are these? Alternate interior. So what do we know about those? They're congruent. So that means that 2y equals x. And then my reason is if 2 lines are parallel, then the alternate interior angles are congruent. Does that make sense to you? Now how many variables do I have? 3. I actually just made my life worse, right? Okay, so if I have 3 variables, what do you think I need? A third equation. You have to have as many equations as you do variables. So look at these angles right here. Are these 3 angles here supplementary? No, because supplementary is a pair, right? It's also not a linear pair because it's not a pair. But do they add to give me 180? Yes, they're just not supplementary. So I can say 2x plus 90 plus x equals 180. So I don't get to use linear pair. I don't get to use supplementary. But when I stick all these angles together, it does make this kind of angle. What's that angle called? A straight angle. So if it is a straight angle, then equals 180 degrees. Okay? So now I have 3 equations. I have 3 variables. I have all my explanations done before I actually solved for anything, because you should be able to explain first or you don't even know how to set it up. But now, okay, I have a system, and you haven't ever even done a system with 3 variables and 3 equations. Do we need to like freak out and quit right now? No, because look at this last equation. That last equation only has 1 variable in it. So it's fine. I can solve that one. So 2x plus 90 plus x equals 180. So 3x equals 90. And x equals 30. So now I can take that and substitute it into my purple one. So that's going to give me 2y equals x, which is 30. So y equals 15. So now, because I'm just using substitution, I'm just substituting all these back in. Now I can substitute that into here. So 2 times 15 plus z equals 180. So 30 plus z equals 180, and z equals 150. Should I put degrees on these? No, because they're already there, and that would be degrees squared, and that doesn't make any sense, right? Okay, so we're going to have to stop here, and we're going to finish these tomorrow. When I give you your homework, I am going to tell you to circle 3 problems, because I don't even want you to look at them until we finish the notes. If the bell rings on me, or even if it doesn't, I'll send out a remind.